Many of us diligently sort our plastics, confidently tossing them into the recycling bin. We feel a sense of accomplishment, believing we're doing our part to save the planet, contributing to a greener future with every discarded container. This common practice, often called wishcycling, is driven by good intentions. We hope that everything we put in the recycling bin will actually be recycled, contributing to a truly circular economy. However, the reality of plastic recycling is far more complex and often disheartening. What if much of our effort is in vain? What if our good intentions don't always translate into actual environmental benefits? The harsh truth is that, globally, only about 9% of all plastic ever produced has been recycled. The vast majority, 91%, ends up in landfills, incinerated, or polluting our natural environment. This stark figure challenges our assumptions and highlights a systemic problem that extends far beyond individual recycling habits. It's a global issue with complex economic, logistical, and environmental dimensions. To understand why this number is so low, we need to delve deeper into the types of plastic we use daily and what actually happens to them after we toss them away. It's time to uncover the truth. The triangular symbol with a number inside, found on almost all plastic products, is the resin identification code. It tells us what type of plastic the item is made from, not necessarily if it's recyclable in your area. There are 7 main categories of plastic, and each one presents unique challenges and possibilities for recycling. Understanding these codes is the first step to truly understanding the recycling dilemma. Number 1, PET or PET, is polyethylene terephthalate. This is commonly found in beverage bottles and food jars. It's one of the most widely recycled plastics, but it still requires careful sorting and cleaning. Number 2, HDPE or high-density polyethylene, is used for milk jugs, detergent bottles, and some plastic bags. Like PET, it's relatively easy to recycle, making up a significant portion of what is successfully processed. These two types, PET and HDPE, represent the majority of plastics that are actually collected and processed by recycling plants. Their clear identification and relatively uniform properties make them more viable candidates. Number 3, PVC or polyvinyl chloride, is found in pipes, window frames, and some food packaging. It's rarely recycled due to its complex chemical composition and the risk of releasing toxins during processing. Number 4, LDPE or low-density polyethylene, is common in plastic bags, cling film, and some squeeze bottles. It's difficult to recycle through conventional curbside programs due to its tendency to jam machinery. Number 5, PP or polypropylene, is used for yogurt containers, bottle caps, and some car parts. It's recyclable in some regions, but its market demand for recycled material is not always high. Number 6, PS or polystyrene, is used for disposable coffee cups, food trays, and packaging peanuts. It's lightweight and bulky, making it economically unfeasible to recycle in most places. Finally, number 7, other, is a catch-all for any plastic not in the first 6 categories. This includes multi-layer plastics, bioplastics, and polycarbonate. These are almost universally unrecyclable through standard processes. Even when plastic is collected for recycling, its journey is far from straightforward. The process involves significant energy, water, and often, extensive manual labor to sort and clean the materials. Once sorted, plastics are typically shredded, washed, and melted down into pellets. These pellets are then sold to manufacturers to create new products. But there's a catch in this recycling loop. This process is often called downcycling. Unlike a truly circular economy where materials retain their original quality, most plastic recycling results in a lower-grade product. Plastic polymers degrade with each cycle. The melted plastic pellets are no longer suitable for making new food-grade containers or high-quality products. The structural integrity of the plastic weakens, limiting its potential applications. Common examples of downcycled plastic products include plastic lumber, park benches, speed bumps, and industrial-grade containers. These items serve a purpose, but they represent a one-way street for the plastic. While extending the life of some plastics, downcycling doesn't solve the fundamental problem of plastic waste. It merely delays the inevitable. These downcycled products eventually reach their end of life. The dream of a truly circular economy for plastics, where materials are endlessly reused without degradation, remains largely unfulfilled. The reality is a linear path with a few detours. So, even the plastics that do get recycled eventually face a limit. They can only be downcycled a finite number of times before their material integrity is completely compromised. What then? Ultimately, a significant portion of both unrecycled and downcycled plastic ends up in landfills. This contributes to soil and water contamination, as plastics break down into microplastics over centuries. Alternatively, some plastic is incinerated, releasing greenhouse gases and potentially toxic pollutants into the atmosphere. Neither outcome is truly sustainable or environmentally benign. Beyond the domestic challenges, there's another inconvenient truth. For decades, wealthy nations have exported their plastic waste, often under the guise of recycling, to less developed countries. These developing nations, often lacking adequate infrastructure and regulations, became the dumping ground for the world's discarded plastic. The promise of recycling was rarely fulfilled. Local communities in these countries were overwhelmed by the sheer volume and poor quality of the imported waste. Much of it was unrecyclable contaminated mixed plastics that should never have been shipped. Informal waste pickers, including vulnerable populations, often labor in dangerous conditions, exposed to toxic fumes and hazardous materials, to salvage what little can be sold or reused from these sites. When recycling infrastructure is non-existent or inadequate, the imported plastic waste is often openly burned. This releases persistent organic pollutants and other harmful chemicals into the air. The unmanaged waste also pollutes local ecosystems, contaminating rivers, soil, and ultimately, contributing to the global plastic crisis that impacts oceans and wildlife far beyond these local sites. This practice effectively allowed richer nations to outsource their plastic problem, creating an illusion of high domestic recycling rates while exporting the environmental and social burden to others. Thankfully, international awareness has grown, leading to tighter regulations on waste exports. However, the legacy of this practice continues to impact numerous communities and environments worldwide. The truth about plastic recycling is sobering. It's a complex system fraught with challenges, inefficiencies, and ethical dilemmas, revealing that our reliance on it as a primary solution is deeply flawed. This realization calls for a shift in our approach. While recycling remains a piece of the puzzle, it cannot be the sole focus. We must look beyond the bin for more effective and sustainable solutions. The most impactful actions we can take are to reduce our consumption of virgin plastics and to reuse items as much as possible. These principles sit higher on the waste hierarchy for a reason. Choosing durable, reusable alternatives for everyday items like water bottles, coffee cups, and shopping bags significantly lessens the demand for new plastic production and reduces waste at its source. We also need to advocate for systemic change, pushing for extended producer responsibility where manufacturers are accountable for the entire lifecycle of their plastic products, from design to end of life. Investing in research and development for genuinely circular materials and robust, locally integrated recycling infrastructures is crucial. Innovation must align with true sustainability, not just convenience. By understanding the harsh truth about plastic wishcycling and shifting our focus, we can move beyond simply throwing things away with hope. Instead, we can collectively work towards a future where plastic truly serves us, without costing the earth.